Welcome to Kindergarten Video on Demand. This video is an overview of Unit 3, How Many? Numbers up to 20. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 3. In this portion of the video, we will review the AKS and indicators of achievement for Unit 3. The AKS is the overarching academic knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of this video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has 5 AKS. Under the AKS, you will find the indicators of achievement, or IOAs. You will also see that we have provided you with the state coding at the end of the IOAs, so that if you are looking up resources on the Georgia Department of Education website, you are able to find the state IOA that is related to the GCPS IOA. Unit 3 kicks off with AKS 1. We have previously worked with this AKS in Unit 1 when we counted sets of up to 10 objects. In Unit 3, we will describe and explain the relationship between numbers and quantities up to 20. Our IOAs help us better understand how students will show mastery of counting sets of objects. To count, students must count objects by stating number names in the standard order, pairing each object with one and only one number name, which is listed in IOA 1.E. IOA 1.B states students must have cardinality and understand the last number counted represents the total number in the set, and understand that even if the set is rearranged or counted in a different order, the count will remain the same. In IOA 1.A, students will count sets of objects in a variety of structured arrangements. IOA 1.F explains that students will represent a given number with a set of objects. The meaning students attach to counting is the key conceptual idea on which all other number concepts are developed. Students will develop successful and meaningful counting strategies as they practice counting and as they listen to and watch others count. In Unit 3, we will do our work with numbers and quantities up to 20 simultaneously with IOA 1.D, where students identify pennies, nickels, and dimes. Know their name and value. We will discuss the name and value of each coin as we count to see how many of each coin type are in each set. By the end of the unit, students will work with IOA 1.C, where they will identify the number that is one more or one less when given a number 1 to 20. With this indicator, students understand that each successive number name refers to a quantity that is one more, and the previous number name is one less. Included in this indicator is an understanding that the new quantity is embedded in the previous quantity. This knowledge will be helpful later in the year when breaking numbers apart. IOA 4.A is taught simultaneously with AKS 1. As students engage in multiple opportunities to count various objects, students identify written numerals to represent a given set of objects 0 to 20. Writing numbers from 0 to 20 is a rote process. Initially, students mimic the actual formation of the written numerals while also assigning it a name. Over time, children will create the understanding that number symbols signify the meaning of counting. Unit 3 is the first time IOA 4.B is introduced. With this indicator, students compare two sets of up to 10 objects in authentic situations. They should identify whether the number of objects in one group is more, less, or equal to the other group. Students should not use symbols, but instead use the vocabulary words greater than, less than, or the same as. While AKS 7 consists of physical and measurable attributes of objects and analyzing graphical displays, the goal of IOA 7.c is for our students to use mathematics to make sense of the world around them by asking questions that they care about and by collecting, gathering, and interpreting data to answer those questions. Students display their data using objects and pictures. Students should be able to use friendly language to explain their data and answer the overall question. AKS 2 is an AKS you will see throughout the year in multiple units. This standard is seen as a progression that is to be met by the end of the year. IOA 2.A consists of students rote counting forward to 100 by ones and tens and backwards from 20. In Unit 3, students will expand their work from quarter 1 by continuing to count forward to 50 by ones and now count backwards from 20 to 0. IOA 2.B expects students to count on from any given number within 100 and count backwards from any given number within 20. Unit 3 will have students work with counting forward from any given number 0 to 50. AKS 6 is also an ongoing AKS, which will be addressed throughout the year. IOA 6.A states that students will describe a repeating pattern with no more than 4 repetitions, iterations, created using shapes and numbers, and extend the pattern, and create repeating patterns of their own. Our work with IOA 6.A will continue to be at the concrete level, with students describing and extending patterns using coins. IOA 6.B states that students will describe patterns involving the passage of time using words and phrases related to actual events. This IOA should be taught throughout the year. This indicator will not have specific lessons devoted to it. Instead, students will work with this IOA in activating strategies and in conversations about their days as they describe patterns related to time from real life.
Chapter 2, Unit Pacing. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at our pacing guide for Unit 3. In the box which names the unit, you will see the suggested pacing. For Unit 3, we suggest about 5 weeks. The big ideas for the unit are included, as well as any links we feel would be beneficial for the entire unit. Next, you will see a list of the AKS and IOAs which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progression for the AKS and IOAs, whether this be the concrete representational abstract progression or progression between specific learning targets within the IOAs. Suggested manipulatives are also included in this left column. The right column provides resources to guide instruction. We will begin Unit 3 counting sets of coins in different structured arrangements. The first 3 days will be at the concrete level with a focus on a different coin each day as we introduce the coin's name and value. Students have already learned strategies for counting sets of up to 10 objects. We will build on this work from Unit 1 to now count sets of up to 20 coins and represent the number of coins in the set with a written numeral. After students have been introduced to the name and value of each coin as they count concrete sets of objects, we will move to the representational level when we count pictorial representations of coins. This allows students to continue using counting strategies, writing numerals to represent the total number of objects in a set, as well as identifying the name and value of the coins. Our suggested pacing for this work at the representational level is about 3 days. On the third day, we will reinforce the order in which we count, say left to right or right to left, does not change the count. The quantity stays the same regardless of the order in which we count. After students have counted sets of up to 20 coins and represented the number in the set with written numerals, students will apply the skills they've learned to represent a given number with a set of objects with IOA 1F. This IOA was first introduced in Unit 1, where students represented numbers 0 through 10 with a set of objects. Students will now do this with numbers 11 through 20. Students will conclude their work with IOA 1D and counting sets of up to 20 objects by sorting coins, as well as describing and extending patterns with coins. IOA 1C is paced next. The suggested pacing for this is about 3 days, 2 of which are at the concrete level as we introduce what it means to be one more and one less. This is paired with IOA 1F as the number which is one more or one less will be represented with a set of objects. IOA 2B, which is our count forward from any given number, will be introduced through a task-based lesson as students apply what it means to be one more as they determine how many dots will be on the screen after the last bell. Unit 3 ends with work on IOA 4B, comparing 2 sets of objects. The suggested pacing for this IOA is about 7 days. Students begin by comparing 2 concrete sets of objects using the matching strategy, and then they will move to using the counting strategy to compare 2 sets of objects. The counting strategy is also used at the representational level. Work with IOA 4B concludes with students applying what they know about comparing sets to construct a set, which is more, less, or the same as a given set. The suggested pacing is about 2 days, with the first day being concrete, when students create physical sets of objects, and then a day at the representational with students drawing sets. In the right column, activating strategies are provided as a teacher resource. Some activating strategies relate directly to the content which will be taught and activate prior knowledge. Often these are embedded within the provided teacher-directed lesson plan for the day. We also provided activating strategies through a slide deck. These activating strategies provide work with AKS 2, our rote counting AKS, as well as IOA 6B, passage of time. The tasks in these slides do follow a progression and are meant to be done in order throughout the unit. Chapter 3, Instructional Strategies. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Now let's take a look at possible instructional strategies that you will see in this unit.
In Unit 3, we are going to focus on counting objects in a variety of structured arrangements, just like we did in Unit 1, but now we will have sets of up to 20 objects. We are still going to use the same strategies that we used in Unit 1, but now we're going to increase the number that we have in each set up to 20. So students still need to be able to know that the last number that they say when they're counting represents the total quantity. Students still need to be able to state number names in order and point to one object and only one object when they say a number that corresponds to that one-to-one correspondence. But now we're going to do it to 20. We have embedded IOA 1.D with these counting IOAs because we know that the names of our coins are conventions of our social system, and that children learn these names the same way that they learn the names of any physical objects in their daily environment, and that's through exposure and repetition. So by using the coins as our manipulative that we are counting, we will continue to expose students to these coins so that they can see it, feel it, touch it, and learn those attributes of pennies, nickels, and dimes as we're counting. So as I present this situation to students, I'm going to talk through what coin this is and make an anchor chart about some of its attributes. We do have some examples of what the attribute chart could look like for coins linked on our pacing guide. So I want students to be able to look at this coin and notice some things about this coin. I want them to know that a penny is copper or brown in color, that it has a smooth edge, it's round in shape. On the front is Abraham Lincoln, our 16th president, and on the back is a building called the Lincoln Memorial. These are just some ways to help students identify this coin. I want students to know that this is a penny and it's worth 1 cent. So I'm going to kind of talk about that before I start my count with this situation. This states that every time Dad drives through Starbucks, he puts his change in his cup holder. These are the coins in his cup holder. What is the name of this coin and how many coins does Dad have? So after you've created an anchor chart or talked about this coin, its name and its value, you're going to do that each time you use coins to count. I want to remind students about the ways that we counted objects within 10. And one of those ways is moving and counting. So in Unit 1, we provided number paths 0 to 10. In Unit 3, we now are going to create those number paths 0 to 20. Okay, so I'm going to have a number path here that I'm going to use as I model for students how I move and count these pennies. So I will move 1 penny at a time, placing it on the number path. We talked in Unit 1 about how we want 0 to be here to show students that this is nothing. 0 is a difficult number for students to understand and grasp, that it comes before 1. So I'm not going to put an object there. So as I count the pennies and move them, I will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we want students to know that the last number we said, that's going to hit IOA 1.B. The last number we said represents this total quantity. So the last number we said is 16. That's the total quantity. As students are counting one object at a time and saying one number name for each object, that's going to be IOA 1.E. Okay, now we also want students to be able to write numerals 0 to 20. Just like in Unit 1, we can still use our number paths to help students compose the number 16. Talk about each digit and how to write that number. So as I'm writing the number 16, I can say for students that 16 is composed of the digit 1 and the digit 6. And to write a 1, I point to the headline and pull a straight line down to the feet line. That is how you write a 1. To write a 6, I'll point to the headline, pull down at a slant to the belly line, curve around to the right, and keep curving until you close the numeral 6. And that's how you write a 6. Students also can touch and count. So if they are ready to move from moving and counting to touching and counting, I may have another arrangement of the pennies in a circle. Move this penny up and say 1. And then I would teach students to continue around in the circle until I get to this penny, which is at the very end. And I would have students just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm counting pennies in a circle, and I'm using the strategy of touching and counting. Students progress from concrete to representational. We will continue to teach the same strategy of crossing off and counting that we used in Unit 1 with objects to 10, but now we may have more objects. So looking at this situation, it says Emmanuel has been saving coins in his piggy bank. How many of each type of coin does he have? Now, this situation would be presented after we have created an anchor chart for pennies, nickels, and dimes, after we've had lots of work at the concrete level, because now we're not only wanting students to count coins, but also to be able to sort these coins by the name and value of that coin. So I would want to teach students to choose one of the coins that they want to start with and focus on that coin and cross off and count, and then move to another coin, and then move to the last coin. So in looking at this situation, I may have students just start with a dime, since that's the very first coin. But students can choose as you're modeling that. That is up to you to decide. So if I'm looking at the dime, I'm going to want to look at each coin and decide whether or not it's a dime. And as I'm looking at the dimes, I'm going to cross off and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to keep track of that, and I may have students just write a D for dime, and I have 12 dimes. So I'm going to write the number 12, and I know that is composed of a 1 and a 2 to make the number 12. Okay, then I would have students count the pennies. I'll use a P for pennies. So I'm going to do the same thing. We're going to cross off and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's also 12 pennies. And then I should just have the nickels left. So I'm going to cross off and count the nickels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 nickels. Now, as you are working with students, one scaffold may be that they need to actually have the coins. So I could build this array out for students using these coins so that they could physically move the coins into categories. I can put all the pennies together, I can put all the nickels together, and put all the dimes together. And then I can either touch and count or move and count, move the pennies onto a number path. I could also use 3 different color crayons or markers, one for each coin as I'm crossing off and counting. It could be another way to organize this for students.
IOA 1C, identify the number that is 1 more or 1 less when given a number 1 through 20. Eventually, the goal of this IOA is for our students to be able to quickly, without thinking, be able to tell us the number that's 1 more than any given number or 1 less. I want to be able to say, what's 1 more than 12? And my kids immediately say 13. What's 1 less than 10? And I want my kids to know that the answer is 9 without them having to draw a picture or anything like that. In order for us to get our students there, we need to build conceptual understanding by introducing what it means to be 1 more, what it means to be 1 less in a context at the concrete level. By building this conceptual understanding of what it means to be one more and one less, we will help build number sense in our students, which will be extremely important for them as they move on into the content and begin to count on when putting sets together, as well as count backwards to be able to just start with a certain number and either count on or start with a certain number and be able to count backwards. So let's look at what this might look like at the concrete level if we're working with the one more. So here is a context. Jackson has 12 pencils. If he gets one more pencil, how many pencils will he have? Well, I know Jackson has 12 pencils, and I can represent the 12 pencils that Jackson has using my counter. So I'm going to go ahead. I want 12. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these 12 red counters represent the 12 pencils that Jackson has. It tells me he gets one more pencil. So let me go ahead and I'm actually going to flip over and use the yellow side to show the one more which he gets. I want to know how many pencils is this now? Well, I know that this is 12 because I built it to represent the 12 pencils. So I don't need to recount that. I'm going to put that number in my head. So 12. And what's the number that comes next? 12, 13. If Jackson gets one more pencil, he's going to have 13 pencils. I can also look at that on a number path. Or you could use your number line or a hundreds chart. Sorry, guys, it's really long, but here it is. So if I look at my number path and I find the number 12 to show me the 12 pencils he had, what's the number that comes next? Because when I count forward, I know my numbers are getting bigger by 1. So if he has one more, I just need to count one more number. And what is after 12 when we count? The number 13. So by building it out with a context that makes sense to our students at the concrete level, this is going to help our students understand what it means to be one more. At the representational level, we can move on to, let's keep our same context. I might not need to use the manipulatives, but instead use some sort of tool like my number path or a number line or a hundreds chart, and I could do the same thing. Well, I know he has 12 pencils, so here's my number 12. And if he has one more pencil, I need to count forward one more number. So 12, 13. Jackson would have 13 pencils if he gets one more. Thinking about one less. Okay, so now Jackson has 12 pencils. If he gives a pencil to a friend, he has one less. What number is one less than 12? Or how many pencils will Jackson have? Again, I'm going to start it at the concrete level. I want my students to understand what is happening and what this looks like to build that conceptual understanding. So I'm going to again start off. Let me use my counters to represent the number 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here are the 12 pencils that Jackson has. He gives a pencil to his friend. So I'm going to take this one and I'm going to take it away, or I can even flip it over. This is my one pencil Jackson had, but he gave it to his friend. So let me think about what number is that going to be? Well, there were 12. I know if I count backwards, my numbers are getting smaller and I want one less. So I need to go backwards one number. So if there were 12 and one is gone, what number is that? 11. I can recount 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to see that there are 11. And then I can also make that connection to the more representational level by using my number path. So here are the number of pencils Jackson had. If he gives one away, he's going to have one less. So my number is going to get smaller by 1. And so how many pencils does he now have? 11. Once our students are good with understanding this and what it means to be one more or one less, I can take the concrete away and move to just the representational level of using that number path or hundreds chart or number line. And then eventually to the point where my kids understand the count sequence moving forward and moving backwards. They know it, and they're going to be able to do it abstractly. Hey, what's one number less than 9? Oh, one number less than 9 is the number I say before 9. So that's going to be 8, or count backwards 1.
In Unit 3, IOA 4.B is introduced, where students will compare two sets of up to 10 objects, and they will need to identify whether the number of objects in one group is more or less than the other group. And they're going to do this using different strategies. And they're going to compare those sets using words greater than, less than, or the same as. So let's look at this situation that we could present to students. And it says, Jamal thinks there are the same number of yellow hexagons as there are green triangles. Do you agree or disagree with Jamal? So as I'm looking at this situation, I see that Jamal thinks that there's the same number of yellow hexagons and green triangles. So what I want students to be able to do is use a strategy such as a matching strategy to prove whether or not Jamal is correct or not. So one way I can do this with the matching strategy is to pair one of the yellow hexagons with one of the green triangles. So I would show students, here's a yellow hexagon, and I'm going to match it with a green triangle. And I'm going to continue to do this. So here's another yellow hexagon, and I'm going to match it with a green triangle. So far I have one yellow hexagon, one green triangle. I have another yellow hexagon, another green triangle. Well, I notice now I don't have any more yellow hexagons left, but I still have more green triangles. So I know that there are more green triangles than yellow hexagons. So I would disagree with Jamal because he thinks they are the same. If they are the same, I would keep being able to put a yellow hexagon paired with a green triangle. So as students are able to do this, they're able to match them up. Another way that this might be presented to students is instead of it being in a pile and they're matching it, it may already be lined up like this. And students may have the misconception that they agree with Jamal because the length of each group is the same. So the length of the yellow hexagon is the same length as the green triangles. And so they may think that the sets are the same. And so that's a misconception students might have. Again, I would want students to be able to move these shapes in order to match them so that we can see which set has more. As students progress through this standard, I may want them to use the strategy of just touching and counting and writing the number. Again, the more we use our number paths, students can begin to see where those numbers fall. So I may pair this with my number path. And as I count the hexagons, 1, 2, I'm going to write that number here. And then I'm going to count my triangles, 1, 2, 3, 4, 5. And write that number here. Students can then look at a number path and see where the number 2 is and where the number 5 is, and be able to tell which number comes first. That's going to be the number that's less, and which number comes after, and that's going to be the set that has more. You may want to put the manipulatives on here if they would fit the right size, so students can see there's 5 of these. I know the hexagons won't fit on the number path, but if I had smaller manipulatives, I could see, okay, there's 1 here and 1 here. That's 1, 2. Okay, so that's another way to do this. As students progress from concrete to representational, we want to be able to provide pictorial images that students will be able to count and compare. We're always going to use concrete objects or pictures when we're comparing, so that students can see the sets. We won't just compare naked numbers to each other. Now, in this situation with representational, we are going to count the picture and write the number. So students will be looking at numbers and comparing them, but it will always be related to a set of objects. So in this situation, Edward went to the Georgia Aquarium. His favorite animals were the penguins and the sharks. Did Edward see fewer penguins or fewer sharks? So as I'm looking at these images, I'm going to talk with students about how I need to first count and see how many penguins Edward saw and how many sharks Edward saw. So I'm going to start with the penguins. I'm going to use my strategy of crossing off and counting just like we did when we were working with AKS 1. So I'm going to use that same strategy as I count my penguins. 1, 2, 3, 4, 5, 6. And then I'm going to represent that 6 by writing the number 6. I'm going to do the same thing with the sharks. I'm going to cross off and count. 1, 2, 3, 4. And I'm going to write the number 4 to represent that set. Now, I need to go back and look at my question because it is asking me whether he saw fewer penguins or fewer sharks. So I'm looking for the number that is less than the other number. Again, students may need a number path in order to find the numeral 4 and find a 6 and be able to identify that 4 is less than 6 or 4 is fewer than 6. So he saw fewer sharks than penguins. In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview.